Hi, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass. I'd like to take a minute to talk about one of our sponsors, Parker Sporlan, and thermostatic expansion valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge-style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as 1, 2, 3. It serves thousands of unique applications. So 1, you just select the thermostatic element for your application. 2, you select the body style you need. 3, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. I'm not even going to ask. I'm just going to let you talk. What's going on this week, Kev?
Well, it's been a bit of a rough week. It hit -9 today in Chicago. So everything was broken. Everything that nobody decided to charge up the proper way is down. Racks down all over the place. Yeah. It was it's been a rough couple days. So a couple things we wanted to go over tonight. It's going to be kind of a weird 2-part episode. So I want to go over some issues that I've been seeing on some startup stuff with some equipment that is an issue all over the country. And the customer really isn't like reaching out to anybody and telling them exactly what to do. But we've had to basically make these things work for the application that they're in. And it's an issue all over the country. So the customer's putting in these grab and go, like drink cases, these QR Hill cases at the front of the store. And most of the time they're in an L. So no matter how you pipe these, I've had them piped 3 different ways. They give you a liquid line solenoid, and they're all on SC3 controllers, and the SC3 controllers controlling the cut in, cut out off of average temp. Now, the issue comes in is they have a condensing unit on the roof. They're generally not on the racks. They're on a condensing unit on the roof that is an Emerson XJ unit with an XCM25D controller. Great unit, but it is massively oversized. When I'm talking massively oversized, I'm talking a 3 to 5 minute runtime.
So my question is, are we sized? It doesn't have capacity control on this specific condensing unit?
No. So it's a fixed capacity condenser. It is so oversized that you cannot even you can't set superheat. You can't get to superheat. You don't even get long enough runtime for the valves because they're standard TXVs. They're not EXVs. They're not pulse valves. They're standard TXVs. You don't even get enough runtime for the valves to calm down and get a good proper liquid feed. So as soon as it gets cold, boom, done, off.
What kind of TD are you running on the evaporators that you're pulling down?
They're like a high TD case. It's like I think it's like a 28 degree evap, and it's a 32 degree discharge air spec.
Okay, so what saturator are you running then?
Like 8 degrees, 4 degrees.
So you're running like a 30 degree TD.
The one today was running 4 degrees.
Wait, 4 degree what? Oh, 4 degree discharge air?
No, evaporator.
This kind of goes back to the podcast that we just put out about the AWES stuff, and how the cold ambient
it may get like an 8-minute runtime, but like these things are so massively oversized, and it's the same setup they ordered for every single one, but they are like so massively oversized that they are just banging on and off, which whatever, they make temp. Okay, they get down to 32, they shut off. Here's the problem. So the way they're piped is the liquid line solenoid basically has to be at the column, and it splits between 3 cases. Okay, well, 2 cases or two 12-footers are in a row. All right, the last 12-footer gets colder every single time because it has a longer liquid line, so it has more to pump out. So it gets more liquid, so it overshoots in temp. So the first one will be 32. It'll shut off, maybe get down to like 31 or 30. The next one gets down to like 30. And then the last case will get down to 28.
That's more than a 2. That's more than a 2 degree. That's unacceptable. You can't do that.
Well, this is where it comes in. Normally, nobody would care because these are all drinks.
Yeah.
Like, there's no perishable food in here. It's Gatorade and Monster and stuff. So they're doing these performance checks on all these cases. They want to see it plus or minus 2 degrees, no more from set point. This is not a rack. Like, this wouldn't even work on a normal condensing unit. Like, you're not going to keep a normal condensing unit plus or minus 2 degrees without, like, literally beating the shit out of it.
No. You could just do it this way. Just, like I said before, when I texted you, I was like, just set it up as a pressure control. Set it up old school. That way.
If you had hot gas bypass and like Tar Group does with their capacity control, that works. Okay, it does. It would work in this application, but like the way they're controlling it and the way they expect it to run is like completely two different expectations here. So here's where the problem comes in. The liquid line solenoid allows it to overshoot in temp. No matter what you do, no matter which way you pipe it, so what I've had to do is I've had to run the TXV in on the last case a little bit to try to cheat. And I mean, I hate doing shit like this, to try to cheat a little bit and not allow it to get so cold.
I got an idea. Put 4 liquid line solenoids at each, one at each case, and have them, basically tied in parallel, so they're all pulling the right voltage, and then shut them down at the exact same time when it shuts down in temp, and then there you go.
Well, the easiest way to do this, which they shot my idea down, would be to put a suction stop in. The way they want to run this needs a suction stop because they expect this down to temp right away, and they expect it to stop right away. So the only way to do that is to flood the coils and use a suction stop. So a suction stop would allow you to back refrigerant up in there and it would immediately stop the refrigeration process.
Yeah,
it wouldn't overshoot.
Yeah, but you'd short cycle like a bastard then too, right? I mean,
really pump down.
You're short cycling now though, right? I mean, you said it's running for 4 minutes and then how long is it off?
I mean, we use suction stops at all the Aldis. Like, we don't use liquid stops there. They have a lot of condensing units on the roof. They don't short cycle at all. They run way better, and they keep way tighter temps because you don't have that initial lag from it coming on and then the lag from it shutting off of it just overshooting temp. I mean, liquid line solenoids for cases suck. I mean, suction stops allow you to have such better temp control, but they don't have that. So here's the problem where the problem lies. So, okay, it overshoots in temp. Now when it goes to come back on, so it has a deadband in the SC3 controller. So at 32 is a set point. At 35, it goes to turn back on. Okay, but there is a 2-minute time delay in the SC3 controller. Okay, there is also a 2-minute time delay inside of the Emerson unit.
XJ.
Yes.
Is this controlled with the XCM25?
Yes. So there's also a 2-minute time delay in there. By the time the 4-minute time delay and the deadband hits, the case is at 42 degrees. Then it comes on, runs for 4 minutes, shuts off, and then it sits there. Maybe like 5 minutes later, it hits the deadband and it starts the timer again. So you get this graph from this billing performance guy. He's going to look at it and he's going to say fail because it's hitting 27 and 41. The swing's too much. So this is where this whole thing is. Now, mind you, I this is like my 3rd trip to this store. I can't stand it when this happens. And we had like 5 of these we failed on. So start talking to a couple other people and what they've done for a couple other contractors come up with. You have to get the day code from Sporlan. You have to remove the time delay for the cut in cut out of the SC3.
Mhm.
So remove the time delay completely. Check the deadband. I found one at 5 the other day. They should be. I've been setting them at 2. And then remove the time delay and remove the time delay from the XJ unit and the minimum off time, because it has a minimum off time of a minute of 120 seconds in there. So remove all that. Unfortunately, now these condensing units cycle like machine guns. I mean, they're not going to last. The compressors aren't going to last. I mean,
Why would they do that?
It's been brought up apparently by multiple contractors, and the
Yeah.
thing is, they're not saying anything to anybody. So like, guys are going back and failing and spending all this time moving sensors and doing all this stuff when it's a design issue. It's 100% a design issue.
They would have to go with some sort of capacity control compressor. They can't put the same unit that they're going to put in Texas as they would in Chicago. You know what I mean? It's a sizing thing. It's wow.
Yeah. So I mean, this is a problem all over the country, and these things are going in all over the country. So, I mean,
So let me ask you a question. Remember when I was frustrated with that one customer, and it was probably about 2 years ago, and you ended up going back and putting digital unloaders on it, and like that day that I was frustrated, I'm like, I quit. I'm taking a sabbatical. I can hear that in your voice right now.
yeah, it's been rough, and of course, we had to go back and fix all these. And today we were going through and fixing a bunch of them. Well, it wouldn't have been that bad, except all the XCMs are on the roof for the condensing units, and it was -10. And yeah, and then every time you go to hit the buttons on the XCM, so yeah,
It was really cold here. It was 44 degrees here today.
hate you. So that's one thing like to watch out for. If you guys are having this issue with that, just get the Daco from Sporlan and remove the cut-in delay. I'm unfortunately it's not right for the unit. It's going to cut the life of the compressor down big time. I mean, all that cycling and contactors and everything else. But at this point, that's the only way to make it work the way they want it to work. Like they should have just put them on a rack.
Well, I mean, someone has to say something, somewhere. I mean, that they're going to be aware of this, because we'll get them under performance, and where there's always a way to figure it out. But as far as the longevity of the unit, I mean, we're supposed to have only 240 cycles max a day on a compressor, right?
So,
no more than 10 cycles an hour. You know what I mean?
Just with the way it was running before all the before all the time delays were pulled out to get it to run.
Yeah.
It was running in 6 hours, it cycled 94 times.
And wait, how long?
In 6 hours.
Ugh.
94 times.
That's almost 400 cycles a day.
Yeah.
That's horrible.
Yeah. The condensing unit is just massively oversized.
Oh, and like you said, it's either hot gas bypass valve, going in the suction with a desuperheating valve,
And the thing that sucks is those XCM 25Ds have the ability to do it. You could order one of those units with a digital scroll.
Yeah, but with supply chains as they are, is that the reason? You don't know why they did what they did. You know what I mean? I mean, if they're putting the same unit in every single store, then obviously they were engineered that way. You know what I mean?
Well, I'm assuming somebody got a deal on something.
I don't know, but that's frustrating as hell. Like I said, I feel your pain. I've been there, done that. I got the T-shirt. And it sucks because you're looking for look to the engineer to basically give you some guidance. Like, how did you guys actually how did you expect this to work? And they're like, "Oh, just do what you can, just make it work." You know what I mean? That's usually the answer you get with some of them. You know what I mean?
So, yeah, I mean, like people don't know what's going on with this, and like I made a Facebook post about it, and then I had like 17 people reach out to me in my DMs about it. Like, same thing, having the same issue, been back there 4 times, still can't get it to work.
And that's frustrating. I mean, because basically the contractor is the one that eats that then, because by their standards, by the performance team, they're basically saying, hey, this isn't up to where it should be running. So it's up to us to play magician and just make it work, right?
Yeah, unfortunately, and like all too often, we get stuck with the.
Today's episode is sponsored by the new Reefer Shield differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Way too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Reefer Shield RDP-01 differential pressure monitor is available now from Westermeyer Industries. To find out more information, email sales@westermeyerind.com. That's sales@westermeyerind.com.
It's a cobbled up mess, basically.
It is. It is.
So, and then we'll talk about the second part of today. Second part of this would be falls right in line with this almost. So, we had a bunch of racks down today, bunch of random racks. We had one store in particular that had a power shutdown. They shut down the power when it was -10 out.
Oh no.
On a glycol CO2 store.
Oh no.
CO2 popped right up, took off running on its own. No issues. Okay. Glycol did not. Fell right in his face, wouldn't do anything. Okay, the power was off for 3.5 hours. It's -10 outside. Dog houses on the roof. So condensers are on the roof, dog houses are on the roof. What had happened is, so all the power went out, so all the gas migrated to the condenser.
Mm-hmm.
All right, so guy goes out there, he tries to get it back going. He can't get the rack to build head pressure, so he grabs a tarp. I mean, not my first choice, but
puts it on the top or on the bottom?
On the top.
Well, so at least makes more sense because the heat's going to rise, right?
Yeah, so he's trying to get it going, can't get it to run. So calls me but in the morning, calls me, and we're talking through it. So this is my tried and true method of restarting a rack, especially if it's on the roof and the receiver's on the roof. I had him close both discharge lines, and I had him made sure the A9 was open, and I had him force a compressor on. Mm-hmm. And what it's doing is it's building pressure in the discharge header, and then it's got nowhere to push but in the A9. So it's pushing all that pressure through the A9. So you imagine a 2 5/8 discharge header necking down to 5/8. Okay, so you're building that back pressure up behind it. Now you're pushing that pressure into the receiver where all this gas is sitting. So now you get the receiver gas going. You get the receiver gas pushed out into the system. It starts, building up more and more and more. Then you open up one side of the condenser, the side that runs all the time, and now you flush all that liquid out of there. And at the same time, you get your suction low enough, you start pumping out the split side, and it usually takes right off. I hardly ever have problems, not starting a rack like that. So you just force everything through the A9 or the ORD valve, and it heats up the receiver, pushes the gas out, and then allows you to build up enough back pressure to push the gas out of the condenser. So like flushing it out. Mm-hmm. At the same time, I usually make sure the A8's open. Well, in this particular instance, it did not work.
Oh no.
So they tried it multiple times. They couldn't get the condenser to build up pressure no matter what they did. They could not get any of the gas out of it. They couldn't get it to run. Well, so finally he calls me back, and this is a EEV store. I asked him, what are the EEVs doing? This is the first time I've ever seen this. He goes, oh, they're both closed.
Oh shit.
Killer. I go, okay, what are they closed because the compressor shut down? We're going through it, we're looking through it. No, they're closed because superheat's 0. Because the rack got so cold that the lines were reading minus 10 and minus 12 because of the ambient temp.
Get the hell out.
It was that cold that the actual TX or the actual superheat sensors, the actual line temp sensors would not read the line temp because the copper was cold. It was ambient temp. Ambient temp was colder than normal running temp.
Holy shit.
So the EEVs wouldn't feed anything. This is on 2 different racks. So B rack and C rack. Neither one of them would feed. So I had to get these guys to warm them up in their hands, grab in their hands, and get them warmed up till everything started flowing. Then the pipe warmed up a little bit, and then finally the rack started back up.
Can you just spray a whole bunch of hot water in the fucking case?
It's on a rack on the roof.
No, but you said the EXVs
are on the rack up for the chillers.
Oh, never mind.
Yeah. And it's minus 12 outside. You want to spray some water?
Well, no, I thought you were talking about like down at the cases.
No, it was so cold on the roof that it had shut the EXVs down because it thought the temp was lower than the superheat temp.
Gotcha. Now I understand. So that's the only reason why basically it wouldn't feed and start building suction pressures because the EXVs were clamped down.
Because they were clamped down all the way because the line temperature was so low that it was actually keeping the valve shut.
Gotcha. I was gonna say because I've even at like minus 27 wind chill, I mean I've had luck with restarting a rack. It might take a little bit, you know what I mean? And sometimes, like the one I was on was basically like a critically charged rack. It was a ViraGuard, so it was already low, and it wouldn't even take refrigerant. Like I couldn't even get the refrigerant in the actual, in the suction because the pressure was too low. So that's when I opted for the slop sink for the refrigerant. But like, yeah.
Generally that's a pretty good way to start it up. Like, these would not go. I've never seen it get so cold that it fakes the sensors out.
That's nuts.
Like it would not run. Like I'm sitting there watching him on a video of him holding his hand, and you just hear the EEV start driving open, and the rack just takes off.
This is in Chicago, right?
Yeah.
I'm so glad I'm not there.
Yeah, it was in Chicago, and it was in Indiana, but it was close to the lake. So,
yeah.
I mean, you're picking up all that cold air off the lake, but yeah, I mean, I generally that's how I end up restarting racks. I mean, and then obviously all the single units that everybody charged in the summertime that
just to a full sight glass.
It's to a full sight glass, or the extra 2 shakes, and they put extra 2 shakes in there, and then call it good. They made it till when it was 20. Well, it's minus 10 now, and all those went down.
I'm surprised it hasn't went down sooner because I mean, you were telling me it's been cold for a minute, right?
We had like a couple snaps here and there, but like it's been like the last 2 days, it's been like straight minus 10. I think it was minus 12 or 13 last night.
Because I mean, usually if the temperature swings, at least like it might run a little warm, like in the middle of the night, and as long as it doesn't go into defrost when it's way too cold, you might be fine. But it's when the cold stays consistent is when all that shit just comes to bear,
Well, yeah, and then I picked up a call on the way home, and same thing. Store with a couple alarms. I get there, it drives. I open up the drive panel, and it's offline. I go up on the roof, and it's an Aldi rack with a CDRU unit on the roof. I go up on the roof, and
hold on. CDRU.
Yeah, it's Husband's version of like their rack in a box.
Oh, okay, all right.
It's got like a rack with a 6 compressor rack with a attached condenser on it. They call it a CDRU.
Okay. All right.
It's a less shitty protocol. So, I go there and drives offline on the mod bus. I go, okay, easy call. Go up on a roof and open up the drive panel. Looking around there, I'm like, okay, drive's got no screen on it, nothing. I'm like, all right. I go to pull the plastic cover off the drive, and it explodes in my face.
Ow!
It blew the bus bar clean off of L1.
Why? What? Why wasn't it shut down?
It it was down, but when I pulled the cover off, the bus bar, it was been the only thing keeping the bus bar back tight against the drive. When I pulled the bus bar off, the cover off and checked power on it, boom, there goes the bus bar.
Oh.
Damn. So, but now here comes the problem with this. So it's -10 out. We have no drive. And if anybody does any Aldi work, they know that most of these are microchannel condenser coils.
Oh.
So we're only running on the last two slabs. But when a fan comes on, it will literally drop your condensing temperature 20 degrees in like 2 seconds.
Oh. So you can't even run it. I mean, what do you do? What did you do? I mean, fan cycling time is what I'm thinking.
Well, I had it. So obviously it's set up for VSS combined. So it's going to cycle the fans too. It's going to do your fans and your drive. So you still have the fan cycling backup. But the problem is it's just all over the place. They get hunts horrible. Yeah. So first thing I do when I have the drive failure, like on the microchannels, I drive the head way up. Like I'll raise the computer set point. So it was 70, it went to 80. Just to give me that buffer, for the so I'm not hitting the holdback. So I'll give that buffer on there so I'm not hitting the holdback valve. Because
so you change the minimum, the minimum.
Yeah, I change the minimum to like 80. I usually go a little bit higher because that way you're not hitting the holdback valve.
Gotcha.
And then on this setup, like make sure the holdback valve was set and make sure there's enough gas in there. The only thing nice about these is it's only 18 pounds per slab. So you only have 36 pounds to completely flood that condenser.
Damn.
So it's not a whole lot of gas, but still, the thing I get more worried about with that is the rapid cycling causes the sections to crack.
Yeah, the expansion and contraction of the slabs. Yeah.
So
yeah, you were talking about that last time.
They generally don't last more than a couple months without the drive. So losing a drive on one of those condensers, if it's not summertime, is horrible. Like right now, like that store is struggling without the drive.
I mean, you don't technically need a Yazaquil, right? I mean, you can go with whatever.
What's that?
I said you don't technically have to go with the Yazaquil. You can go with something else, yeah?
No, this is a Emerson M400.
Oh, okay.
Yeah, unfortunately, you really can't go with something else here because they're actually using the mod bus to control everything, so there's no AO card.
Gotcha.
So that's where it becomes kind of a pain. I mean, you could slap a Danfoss in there and make it work, but
listen, Johnson Controls makes some nifty pressure controls that do some nifty shit. So like if you need to control an analog output, you know what I mean? You don't have to extend out get an AO from the EMS because you don't have one. I mean, you basically put a Johnson control. It's almost like a pressure switch, usually digital, and you could set it up exactly like a loop sequencer. You know what I mean?
Well, that's why I like the Danfoss drives. Like that is cake on a Danfoss drive.
Yeah.
To set up the control of pressure.
Mm-hmm.
Like you don't have to do like the Walmart style, but you can set a Danfoss drive to control up off the transistors so easy.
See, I have a steady. I have a one of the displays from an old drive that grenaded, and basically I have that Danfoss program in there just in case. You know what I mean?
For me, and then also I have it on my laptop. So all you need is I think it's an S cable. It's a USB to USB S. It's like that square looking cable.
What? Hold on. The one that's like almost like a trapezoid, or are you talking about the one that's like a full like oval? That's the
I
C.
think it's trapezoid. No, it's the one like all the printers take.
Oh, that's the okay. The it's like USB 2.0 or something like that or something. I don't know. I know what you're talking about. Printer
Yeah,
cable.
it's the one that printers take. So you can actually plug that into a Danfoss drive and then download the VLT program, and you can do all the programming for your computer. It's free. It's great. Takes half the amount of time, and you can save the program on there, and you could just dump the program in for your laptop.
The 2.5 hours we talked to freaking Matt, and he didn't mention shit about that.
Yeah, I talk to you all the time. Like it's literally cake. Like you just see that plug. You can find I probably have like 6 of them in this house somewhere from like appliances you get or like stuff you get like literally this power supply I found the other day. Literally had one in there.
See, I have 2 in my bag for communicating to the boards with RDM, because you can do it via Ethernet, or you can do it the USB to that printer type cable.
Yeah, so I mean that's great to carry around, like especially for like if you're doing a lot of drive work, like swapping a drive out, and then the Yaskawas. I'm pretty sure you can plug a USB right into those things, and then you saying that you can get on the computer with those too. The M4 is the only one where you have to buy a program.
Well, either you could probably if it's BACnet, you could probably use a USB to BACnet card, and as long as you have the program, you could probably figure out. Hey, Hassan Kubrick, if you're listening, he works with a lot of Yazuka. Send me the program for the Yazuka.
You can download off their website.
Yeah,
it's on the website.
gotcha.
But the Danfoss ones are cake. So I don't know. Like this is obviously going to get an M400 put back in it because I don't feel like remounting everything and everything else. So, and plus they're all the same at every store, so I don't want to confuse people.
Yeah, I got you.
But
apples for apples.
Yeah, I mean that was basically how my week's been so far. So it's still -10 off. So I'm sure it's going to get worse tonight. So
I was a chiller mechanic this week.
Chiller mechanic, eh?
Yeah. Well, I mean, so we were trying to figure out. We've had low flow issues on some of these chillers.
Like water coolers, is that what you're considering a chiller mechanic?
There was train chillers that has a system. We had to go through find all the prints and try to figure out the basically how it was supposed to run, because I mean typically you have a VFD trying to control the end of the loop or 3/4 of the down the loop, trying to control the differential pressure. But on this particular one, it does do that, but then it also has a bypass, from return to supply water. And basically what it's doing is, in this instance, through Niagara AX, what it's doing is it's trying to control the actual pressure difference across the heat exchanger. And by that, they're actually doing a formula to figure out what the actual flow rate is. So part of the problem is that, forever, the bypass valves had an override for, the guy said years. And part of the reason is because 2 out of the 3 pressure transducers sets that, basically calculate the differential are not reading. And then 1 is just not reading it, properly. So it's making the bypass do some crazy stuff. So you're not getting the proper flow across it, because we were going to, our mechanics were going to have it balanced. And I was like, man, we got to get the controls working first. And once we get that, then we can get the system balanced. Because I'm sure, pumps have been changed out numerous times. So I'm willing to bet dollars to donuts that, the circuit setters that were shut off to change out the pump are probably just wide open. You know what I mean? So the circuit setters on there are probably not set up properly. So once we get all the controls working properly and we know we're getting the right, GPM calculated across with the bypass, then at that point, then that's when we set up the circuit setters. That's why I called you the other day trying to get the part numbers for the P plugs.
Yeah, having those Pete's plugs is like a great tool to have. Like, I mean, you don't use them all the time, but like we do a lot of work at some bigger buildings. So, I mean, you have a lot of water cooled stuff. So, I mean, having that Pete's plug there is a great way to grab pressure tap readings if you need them. And then also, if you guys are trying to get like glycol line temps, like I'll do this a lot, is is like a Cooper, like a DW 450, I think it is. It's like a little yellow line stab thermometer that like a lot of cooks use. They're like $27 on Amazon. Great thermometer for what we do, like to keep in your bag to like check on stuff. So
Yeah,
don't put I mean that Cooper, and then most of them, and I think the Cooper Redbox one should fit too. You could stab that in the Pete's port plug.
Yeah.
And then you can get the actual line temperature, not like clamping it to it. You can get the actual flow through line temperature.
Yeah. No, that's what we ended up doing. We ran, well, you know, because no one had the particular fittings. We just ended up having to go to Granger and getting, you know, the full on kit. Well, the gauge is actually pretty cool that they use. I mean, I'd rather like to use a digital gauge, but you know, the gauge that we had basically had a marker on it, so you could see what it was before, and then see what, you know, on the one side, so you didn't forget what the setting was, so you could actually look at it and see what the differential is actually giving you. You know what I mean? But
yeah, what I actually do is I take my field piece probes,
yeah,
and I use those. So I take a 1/4 inch adapter on the Pete's plug adapter, and I put a 1/4 inch MPT to male flare, and I just use the field piece probes to get my pressures. Works
yes,
great.
that's what my wife just threw to me before when we were talking. So
Yeah, I mean that works great for like grabbing pressures and stuff, and like temps if like you're doing some glycol stuff or some balancing. I mean, obviously you should have a delta P sensor, or you're trying to read delta P across something. Um, that works a little bit better, but I mean, we're not balancing stuff like in balancing is an art and a trade in itself. So I mean, we get things close. Like I'm not a balancer. I don't claim to be a balancer. That is literally a trade of people.
I can get it in the ballpark, you know, using that HY Tools app, you know, that I did that little small little video on, utilizing that. Like, I mean, I can get it in the ballpark where the thing is running right, but I mean, it's not a true blue balance. You know what I mean? It, you know, like you said, that's a specific trade in itself, my friend.
Yeah, I mean, it's getting it close and getting your flow rates right. I mean, that really matters a whole lot. I mean, but like I said, you know, you're not going to go out and spend $900 on a balancing kit. That's not something we use enough to, you know, warrant that.
Well, cool. It sounds like you had a very eventful week. Well,
Yeah.
the weekend's approaching, guys. I'm going to be over at AHR starting Monday. Monday and Tuesday, I'll be at the Sporland booth from 12:30 to about 5:30 or 6. I think Monday we're doing a live stream with Chris Stevens from HVACR Videos. Come visit. They're giving away Sporland's giving away a Zoom Press tool. So come visit. I got stickers and patches, and you know, we're gonna hang out and we're gonna have some fun. So, other than that, guys, you guys have a great weekend, and we'll see you next time.
Take it easy.